And good afternoon, everyone. My name is Kurt Ledger, and I'm the Director of Sales for the Energy Management Association. Thank you for joining us for another EMA webinar. Before we get started, I'd like to go over a few housekeeping notes. The presenter will periodically answer questions throughout the presentation, so we encourage you to submit them at any time using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform the panelists, and our technical experts will assist you. This presentation is being recorded and will be available for viewing in 1 week. Finally, in terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. Today's webinar is Making Fenestration Part of Your Overall Energy Management Plan, presented by the National Fenestration Rating Council. And to start things off, we have a poll question that we would like you to answer. What is your professional background? Please feel free to make a choice from any of those being offered there or others. Our speaker today is Kevin Lauder. Kevin Lauder joined NFRC in May 2017 after spending 17 years in the fenestration testing industry and is the senior manager for the commercial program. He began his career as a test technician for the Architectural Testing Incorporated in York, Pennsylvania, eventually becoming the manager of the Thermal Testing Computer Simulation Department. Kevin has a Bachelor of Science degree in Mechanical Engineering and is a licensed engineer in training in Pennsylvania. Thank you all again, everyone, for joining us. And with that, I will hand it off to our expert, Kevin, to kick things off. Kevin?
All right, thanks, Kurt. Just taking a quick look at the poll here before we get started. All right, that's good. Looks like we have a lot of consultants, architects, engineers on the call today. Okay, as mentioned, like I said, my name is Kevin Lauder, Senior Manager, Commercial Programs at NFRC. I've been involved in the fenestration industry for over 23 years now, and I've seen a lot on the testing side, and I've seen a lot on the certification side. Just to give you a little bit more information about myself, I've been involved in a lot of projects related to museums, sports stadiums, universities, educational institutions, courthouses, hospitals, casinos. In the pictures here, some of the most notable ones I've been associated with is National Museum of the Marine Corps, New York Transportation Hub, the Seattle Space Needle, the Seattle Tacoma International Airport, LaGuardia Airport, Mercedes-Benz Stadium, home of the Atlanta Falcons, Dallas Cowboys headquarters, Louisiana State Museum and Sports Hall of Fame, and the Minnesota Multipurpose Stadium. Also, NASA Research Center and the NASA Goddard Space Flight Center. Primary work on the testing side was focused on thermal performance, condensation assessment, whole building facade analysis, and durability using thermal exposure. On the certification side, I've been involved with auditing and training, research projects, and overseeing the commercial certification program, where I've been instrumental in developing a new rating procedure for commercial products using a trendline methodology, which I'll briefly touch base at the end of this presentation. So today's presentation will focus on the importance of energy efficient fenestration in commercial building and how to use fenestration as part of an overall energy efficiency plan that meets code requirements. Before we get started, the term fenestration may or may not be a familiar term. I hope it is familiar, but for those that it's not familiar, fenestration encompasses products that fill an opening in a building envelope, such as windows, doors, skylights, curtain walls, storefronts, etc. That are designed to permit or limit the passage of heat, light, air, vehicles, or people. These products are barriers which help to regulate the interior environment from the exterior environment. Primary performance metrics to determine product efficiency and occupant comfort include U factor, solar heat gain coefficient, visible transmittance, Condensation index, which is replacing the condensation resistance value, and air leakage. Various combinations of framing types and materials and glazing infills can produce significantly different results. As many of you may know, examples of framing types and materials include wood, vinyl, fiberglass, steel, aluminum, aluminum with thermal barrier, etc. The frame conductivity and configuration can significantly affect the thermal transfer, and it can also be a major consideration for strength, durability of the building application. If you're designing for wind load, story drift, etc. You might not want to put a vinyl window in a large high rise due to some of the story drift or wind loads. Some examples of glazing infill characteristics include multi-layer configurations like your double glazing, triple glazing, incorporation of low heat coatings, and applying them to various glazing surfaces. That'll affect your solar heat gain. In some cases, it's going to affect your U factor depending on how many different layers of low heat are applied. There's different gas fills, air fill, argon, krypton. Krypton's not typically used a whole lot due to cost, but I'd say argon is one of the primary go-tos if you're not using air fill. Different spacer system technologies. There's warm edge technologies out there. You need rigid seals or soft seals depending on, like I said, application. Applied films and laminates. The topics for today's presentation will describe energy consumption related to fenestration in commercial building, provide information on code requirements and compliance documents, provide some consideration on how to reduce building energy consumption through proper management and methods that can increase occupant comfort. The focus on today's presentation will be on new construction and total replacement on existing building. Let's begin with some energy consumption related to commercial fenestration. Much of the time, fenestration, including consideration of energy efficient fenestration as a default selection, is often overlooked and not considered in the build design phase due to several reasons. Let's start with new construction challenges. Typically, building owners, architects, engineers are trying to achieve a certain building aesthetic through custom configurations and non-standard stock products. As a result, these systems require additional certifications to be performed, which many of the times are one-off configurations specific to that building or project, and therefore not evaluated. Oftentimes, designers are more willing to use familiar products, ones they've used in the past, knowing their success rates, and are hesitant to try newer technologies, especially technologies that are deemed a higher risk or even a higher cost. Focusing more on life threat and safety of the building, like fire suppression, fall protection, anchorage, while value engineering fenestration. Typically, as a result of that, fenestration products are being selected with reduced performance ratings, some which have no certification to confirm their energy performance for the building, and all of this, really affects building energy consumption and comfort. Again, going along with some of the new construction, the last item is design teams focusing more on trade-offs to meet the building energy code requirements, such as lighting, plug loads, HVAC. In many cases, teams devalue the fenestration for cost savings, but this negatively affects the aggregated long-term energy use for that building. Over time, what you may have saved with that one trade-off, you could have been saving that the whole time with the fenestration. Now let's go into some existing building challenges. And these have direct impact on energy use. So oftentimes when someone's considering a replacement, they may only consider one component to replace. So as an example, some people, they immediately go to, let's change out the glazing, see if that helps. If you don't do a full assessment of the fenestration product, perhaps you're installing a new glazing, but you didn't evaluate the framing system, and you may have thermal bypasses in the system, flashing bypassing thermal breaks, or potentially you may not even have a thermally broken system, some of the older buildings. So just changing out that glazing, it's not going to benefit because the frame is going to be controlling that energy use, or the energy is going right out through the frame. You know, with that glazing improvement. Additionally, when you select, say, a glazing component, you have to look at all the performance metrics. If you're just changing out the glazing for U factor benefit and you don't consider the solar heat gain associated with that glass, you're gonna heat up the building much more quickly if you have installed a higher solar heat gain product than what was originally installed. So again, there's caution on doing a full assessment of what you're doing. Sometimes the individual component is not going to work for you. Example that I experienced personally, there was an installation that happened, brand new installation. They thought they were doing well, and the occupant comfort was affected greatly because they installed the low E on the wrong surface. So they thought they had the low E on the number 2 surface, which would cause less solar gain to the interior of the building. But for some reason, it was mismarked, and the installer installed it with the low E on the number 3 surface, which would allow more solar gain to the space. So like I said, it wasn't that the glazing was wrong, it was just incorrectly applied to the building, causing a thermal comfort issue. So that's one item to, again, be cautious of. Other existing challenges associated with an existing building are band-aid methods that get applied to the building rather than addressing the windows themselves. I've seen HVAC modifications where they change out the ventilation system, which blows directly across the window assembly. And the main goal of that was to wash the window frame, to try to heat it up and to wash the condensation effects off. If any condensation would build up, that the when washing across the window would dry up that condensation, which, like I said, doesn't really solve. I mean, it visually solves the issue, but doesn't permanently solve the main issue going on there. Also seen blinds or curtains being installed to regulate solar gain or trap convection from air infiltration of the window to the room, which again, that's another Band-Aid type item. Additionally, adding portable heating devices into the space to try to improve the comfort, which basically you're increasing the energy use because you have supplemental heating to provide that comfort in the room. Like I said, while these methods may work in the short term and it minimizes occupant, when somebody goes in there to do a major installation or a major retrofit, you're doing minimize the occupant discomfort there. But like I said, these are not long-term solutions, and it doesn't, like I said, it doesn't fix the main issue associated with that fenestration product. And any window replacement, consideration should always be how will the window replacement be performed, and how can it be certified? Why is the certification important? This is the only tool that you have that can confirm product performance. It'll help you aid in retrofit selection because you'll know what you had, what you're replacing it with. And the certification itself is required in codes. So it's important to note that only full products can be certified, not individual components. The only exception to that is applied films. So let's dig a little bit deeper into some figures for energy consumption for commercial building. Buildings represent the largest sector of the U.S. energy economy, accounting for 39% of total primary energy use. About 18% of that energy is of all energy consumed is from commercial building. 36% of it is electricity related. While these numbers are not specific to solely the fenestration, it considers the whole building, it's important to benchmark and track energy use to realize progress and improvements in buildings. Energy consumption does depend on the building type, the size, the vintage, and the occupant use preferences. Space conditioning, heating, and mechanical ventilation is the primary energy use in commercial building. Lighting is also a major contributor to the energy consumption. Fenestration can significantly impact heating and cooling loads due to the heat gains and losses, and the amount of daylight levels can affect the lighting requirements. Adoption of energy efficient commercial fenestration with certification provides an immense opportunity in energy savings in buildings. In the US, approximately 360 million square feet of vision area glass is sold every year. And this is from Guidehouse. And this includes new construction and retrofit exterior applications. And why is that figure important? This means that there's a significant number of windows being produced, and each one will have an impact on building energy use. The link down there in the bottom, if you wanted more information on a commercial research study, you could go to that address there and get some more information related to commercial research project. So let's look at building stock greater than 20 years old. Not very good for energy savings. Approximately 65 to 70% of commercial building stock was installed over 20 years ago, and only about 14% has undergone some type of retrofit. So you're looking at over 50% of buildings with these types of criteria. These buildings are the least efficient and consist of 41% single pane glass. There's 42% with some type of low E, and 58% just have an airfill, whether it be a double pane or triple pane glazing unit. And another important aspect here is 21% are only aluminum. Only 21% are with a thermally broken frame. So the remainder of those are just other systems, aluminum, non-thermal broken. So that's not very good by way of the frame there, the frame performance. Now let's look at buildings installed less than 10 years old. Much better figures here. These types of buildings are incorporating more energy savings technologies, and that's primarily as a result of some of the codes that were implemented. So 88% are double pane. There was 4% triple pane. 83% are using some type of low E coating, and now 68% are using aluminum frame with thermal barrier. What they said, it's a lot more thermal resistive type products are being used in the newer vintage buildings. So all these improvements are in the right direction to save energy, but aggregated energy use across all buildings. The older vintage buildings are still consuming a significant amount of energy and resulting in poor aggregated energy use numbers until these replacements are performed. Now let me just see if we do have any questions real quick. I think we're okay. All right, let's go into discussing fenestration requirements for code and what compliance documents are required for code. Okay, so two main documents for commercial products. The primary energy standard is ASHRAE 90.1. The IECC, International Energy Conservation Code, does refer to ASHRAE 90.1 for commercial products. It should be noted that each state adopts different versions of the code. So there's no nationwide code version mandate. Additionally, with each code revision, the prescriptive fenestration requirements typically become more stringent. So if you're on an older version, some states are on 2016, some are on 2018, 2021, I believe is the recent one. But at each version adoption, those performance requirements are revised. So what are the requirements in 90.1 for commercial products related to thermal performance and fenestration? Step one, the testing standards that are required. So NFRC is the only recognized certification for thermal performance and energy code. Commercial products are required to have U factors determined in accordance with NFRC 100. The solar gain and visible transmittance determined in accordance with NFRC 200, with maximum specified in tables 5.501 through 5.508, or just 8. While on the surface, when you review these standards, they appear to be only computer simulation standards. There are specific requirements that a physical validation test be also completed to validate the computer simulations. Only when both the physical testing and the computer simulations are completed can the 100 and 200 testing requirements be deemed completed. The left-hand side picture here, for those that work with computer simulation or do some modeling, that's what a curtain wall model could look like. On the right-hand side is a depiction of what the thermal chamber for a hot box construction would be. There's a hot side and a cold side. The product gets installed in the center, and basically, for simplicity, whatever the heating requirements are to maintain an interior temperature, the heating load there will determine that thermal transmittance. One thing to note, laboratories performing these procedures are not authorized to produce labels or label certificates for products and must submit the reports and data to an inspection agency, where they're reviewed and determine product or component authorization. Reports generated by the NFRC accredited laboratory have clear reporting requirement language on them that indicate that the results are not for compliance until authorized by an NFRC licensed inspection agency. So while the tests may be or have been completed per the standard, the reports themselves are not the compliance document to satisfy code, and these should not be accepted for code compliance. As far as air leakage requirements, those need to be performed by AMA, WDMA, CSA 101, IS2 A440, NFRC 400, and ASTM E 283. So all those any of those testing standards would be required to complete the air leakage requirements. Step 2 for the code compliance, products must be labeled or have a signed and dated certificate provided listing U factor, solar gain, visible transmittance, and air leakage rate. First option that we'll talk about here is primarily geared for factory assembled products. Certified product must leave the manufacturing facility with both a permanent label and a temporary label on the product. The right here depicts what a temporary label would look like that would be applied to the product. And this would be removed after installation and inspection. Note, if this label is not affixed to the product when it leaves the manufacturer, it is not considered certified, even if the product is authorized as a certified product. The next available option for the label would be a site-built certificate. On the right here is an example of what the site-built certificate would look like. So you can get an idea of what to look for in the project documentation. This certificate is used for field or site assembled products, typically used if condensation resistance is needed for the project. The next item I'll talk on the next slide, CMA, does not include condensation resistance. It's important to note that the labels for this certificate, that they're not affixed directly as the product. It is a certificate, and that is the compliance document that would be placed in the folder, and that would be used if the product's going to be reviewed or inspected. As we said, next one here, CMA label certificate. This is the final labeling option that would be produced by an approved calculation entity, or we call them an ACE. And they need to work for an ACE organization to produce the label certificate. Generally, the responsibility at ACE, they assemble the framing, glazing, spacer system, produce performance ratings for products on the project under the direction of a specifying authority. Should be noted that an ACE can generate bid reports as well, but these should only be used in the bid design phase. That bid report is not the compliance document. Only the label certificate is the authorized compliance document. And again, like I said, the products are not considered certified until the compliance document is produced. And now the final step per the code, code compliance requires that the performance values be determined by a laboratory accredited by a nationally recognized organization. And in the code, it specifically says such as NFRC. Not anyone, such as a consulting firm or a manufacturer, can test and produce energy performance ratings. So again, a caution on those accepting reports for compliance documents. Ensure where the documents are being produced so that you can assure that you're meeting the code requirements. Okay, now that we reviewed the code requirements, let's dive into some confusion and acceptance issues that I've seen. First item here, what does code require? So we just described what code requires. Again, they got to be tested according to the standards, must be performed by an accredited laboratory. Products must have some type of labeling, like whether it's affixed to the product or the certificate. However, there still seems to be confusion out there in the market on what is being accepted out there, and what does actually get accepted. Next item here is, what does the product specification require? So one of the items I've seen is, if a product does not meet the product specification performance values, the products are often reevaluated at the project size or alternative configurations, which again that's not in compliance with NFRC 100 and 200. Those are standard size configuration type products to comply with 100, 200. So essentially what this does is, when you do the alternate sizes or alternate configurations, you potentially meet the specification due to larger glass to frame ratio, which lowers that U factor. But again, that does not meet the intent of the energy performance specified for the project. Again, that could essentially reduce energy savings because it's, again, not evaluating those products according to the standard size. And why is that important? Comparing prescriptive requirements to performance requirements, many of those prescriptive tables are based off of, they were developed on some type of standard size product. So if you're evaluating to the performance and doing alternate sizes, you're not apples to apples comparing anything there. So that can create some problems. There's a lot of time and effort invested in, establishing some of those default tables. And like I said, when you deviate, it doesn't create a good situation. One thing to note, though, that alternative sizings can be provided for the project. I know, you might need the alternate size for HVAC design, sizing of the HVAC equipment. But again, like I said, those should be for informational, those should be for energy calcs, and that's not for code compliance. What compliance documents are being accepted and who is reviewing the project? So we have a couple items here. Certified labeled products, bid reports, manufacturer reports, laboratory reports, professional engineer stamp. So there seems to be some confusion on, essentially, if somebody's reviewing the project and when they review it, what documents are they accepting? The only one that, like I said, is approved for code compliance is having that certified and labeled product. None of these other ones comply with the code requirements, and essentially you're opening up that project to litigation if somebody does review that project down the line. Project the problem compounds on this when inspectors' time is not necessarily allotted to verify energy code compliance. Their time is more allocated to other aspects of the build. So the time that they're allocated, like I said, fenestration sometimes gets put off or does not get reviewed as it should. And in some cases, some of the code officials are hesitant to delay construction due to lack of fenestration compliance. Confusion again, we talked about requirements, computer simulation and physical testing. There's always confusion on, is the physical test actually required? And yes, the physical test is required, but it's not required on every project. It's required at the initial certification of the project. It's required, or the product, excuse me, not the project, the product. And it's also required at recertification of the product. So the physical test doesn't have to happen every time, but it does have to happen to basically verify or validate the simulation. Since NFRC product certification is voluntary, some manufacturers see certification as a burden and only see this as an additional cost and should be focusing on their priorities on the project. However, without the independent review, how can you confirm that the results that you're getting are, unbiased, or how can you confirm that accuracy? Sometimes you see people will perform the testing, but don't follow through with the certification. And again, this creates problems down the line for specifiers trying to find certified products to meet their code requirements, and they can't find them out there because there was no certification for the product they may wanted to use for that project. Another aspect is if the certification is confirmed up front, this may potentially put a product ahead of another product because that certification was confirmed and they can move forward with the project. Whereas if the certification was not there, so that could cause delays, which many of these commercial builds do not have. These are fast-paced projects. They want to get them up and running, get them occupied. Another item is that aids with the certification is if you can prove high performance product. In general, this drives competition in the marketplace, and it also drives product innovation, new technologies to the market, and all of those help consumers, building owners, helps the occupants, and everybody's able to potentially have some energy savings with some of these higher technology products. Later in the presentation, I'll briefly talk about some glazing technologies that are aimed to try to save energy. Now let's discuss some considerations to reduce energy consumption and increase occupancy comfort. Starting out, like I said, in the design phase, perform a comparison of certified product performance ratings and select the best possible performing fenestration that could be afforded for the project, or at least at the current code or project requirements for the location the building will be constructed. Striving to go above code requirements. If you follow any of the voluntary stretch codes, not only increases energy savings, but may result in pushing out a window retrofit or replacement later in the building's life. If you're already at a certain level now, like I said, depending on how the code progresses, you could be good for many years, depending on, like I said, the energy requirements. In cases where window products have already been specified for the project, oftentimes the designers, they automatically know what product they're going to use for the project. It's always important to follow through with that certification. So again, so you can ensure compliance with the code and the project specification. Having certification data will also allow for benchmarking and tracking of building stock in the region and can be used to assist others in general product selection and understand when code updates may be required or adopted for that region. As each state has different code version adoptions, like I said, potentially tracking all of this will be better able to see what fenestration is out there, what's being used, and where are the areas that need improvement or not. As a consumer focused organization, it's important to know what you're getting. So again, certification through independent laboratory and inspection agencies is extremely important. You can be reassured that the performance values are accurate when they're certified. Okay, whether you're constructing a new building or performing a replacement on an existing building, you need to know what you have before you go trying to install or upgrade. Again, the importance of obtaining that product certification is paramount and the best tool to help determine what will be or what is installed. Without that proper information, you could be installing a lower performing fenestration and reduce your building performance, which you don't want to do. And just briefly looking at the two examples here in the slide, different performance ratings here. You can see the different U factor and solar heat gain, visible transmittance and air leakage are identical. But say you had this example that the original building had a 0.35 U factor, you're looking for 0.27, which is great. But then for some reason you might want a 0.32 solar heat gain that the original Windows had. So again, the one on the right meets your U factor but does not meet your solar heat gain. So at that point, you said you want to look out for additional data, figure out which framing glazing package meets the goal for your project. So again, the only way you can really verify that is if you have the certification data in front of you that you can look at to best educate yourself on which, like I said, product and glazing package to use for the project. To further understand any gains and losses on the building as well, there's energy modeling. The ones that are recognized by DOE are ComCheck, Energy Plus. A lot of the individual states have their own energy modeling software, their own versions of the modeling software that are used. And again, with the energy model, so that's not code compliance. That's just trying to understand the energy use. Those types of softwares will help you with, it'll help you plug in fenestration, the lighting, mechanical systems, plug loads, to help you figure out the energy use for the building. Next item here, window to wall ratio. So depending on the type and use of the commercial building, the fenestration will comprise of a specific window to wall ratio. And regardless of the window to wall ratio, fenestration needs to be considered in that energy use of that building. This also includes roof, the roof when skylights are being used. Potentially skylights are being implemented to reduce the lighting requirements in like warehouses, retail outlets. So again, that all needs to be incorporated into that energy use calculation. The fenestration in some cases, again, I want to stress in some cases, most people think the fenestration is always the worst performer, and that's not necessarily always the case. But like I said, most people assume that that's the low performer. And again, just wanted to stress that you need to include the fenestration, how big or small, to figure out the energy use of the building. So building use, it will typically help designers determine the window to wall ratio. Larger fenestration sizing is typically used in higher occupancy buildings to improve comfort. People like to see out. They like to be exposed to the outdoors, allow that natural lighting in. Whereas say like a warehouse type situation, not a whole lot of occupancy there. They may be tolerable to have that lower window to wall ratio. And again, one thing to note here is having a small window to wall ratio does not necessarily mean less energy use. That's a common misconception. I think when local law 97 came out in New York, everybody was concerned about low window to wall ratio. Like I said, smaller windows being installed. But having a small window, again, does not mean less energy use. It's all dependent on what's installed into that opening and what performance level is being selected for that. Current trends that I've been seeing is window to wall ratio is growing in newer constructions, and I think a lot of that is potentially stem from the pandemic times where again they want more light to come in. So when obtaining the product certification, all products, again, just wanted to stress, they're tested at a standard size, so the products can be compared equally. This information is typically not helpful when you're doing energy modeling, when the window to wall ratio deviates from that model size. One thing to keep in mind, though, that supplemental information can be provided if you're going with the CMA route and producing that label certificate. There are size-specific performance values that are available. Those are for informational purposes only. Again, that's for use in energy modeling, not for code compliance. But both values are provided. The standard size values for code compliance and the custom sizes for anything you might want to do energy modeling related. Next item here, climate zone. Climate zone can significantly be a deciding factor on what fenestration or what performance ratings you might be looking at to improve the building performance and comfort. In general, all the ratings are important, potentially some more than others initially when you're reviewing for the project. Examples here, cold climates, U factor is typically the most important to start with. You're interested in maximizing heating costs or lowering the heating costs, so that U factor is important. The lower the number and the U factor, the better. That's inverted from our value. The higher the number there is better. But so windows get rated as far as U factor. In hot climates, the solar heat gain becomes important to determine your cooling requirements. The lower the value is better in hotter climates, as the lower the number, it allows less gain into the space. A higher number could be tolerated in potentially cooler climates, so that you allow more gain in the wintertime. In either hot or cold climate, having the appropriate visible light transmittance is important for lighting requirements, occupant comfort. It's useful, again, when you're looking at window to wall ratio and building use. Just quick example for visible transmittance, a light, bright space may be more appealing, to a high occupancy area, and not using, highly tinted glazing to control that solar gain. Like I said, that could be a detractor. You have maybe a nice, bright or big window to wall ratio, but you apply such heavily tinted glazing that it, doesn't provide that comfort level. Condensation index rating, that is an optional rating. Like I said, that's replacing the condensation resistance rating. That can help determine expected condensation formation on the product. The higher the number, the better. The higher the number, the more resistant that product is to resist condensation formation. And then the final item here, air leakage. That is important to understand how much air is flowing in or entering into the building. Too much infiltration results in drafts, occupant discomfort, as well as it can increase potential localized condensation formation. You have cold air coming into a warm space. It's high humidity area. Good probability you could get some condensation at that leakage point. Building location and direction can be important. Aesthetics on the building is a major consideration that the design team has to consider. Typically, one glazing makeup is used for the entire building. That's not always the case, but the majority of the time, one glazing is typically used. While this creates an appropriate aesthetic for the building, it's all the same glazing. You're going to get the same color levels if you're doing any type of tinting across the building. It could be cost effective to install that, single glazing. You're not dealing with multiple glazings, and there's could be a potential less chance of installation error. But this all can be improved with proper planning. One thing to consider is designers may consider using different glazings on the different elevation sides. Your high exposure sun locations, like your southern, western elevations, you might want to have a lower solar heat gain type glazing on those elevations to address heating of the space. Whereas you could potentially switch up the low E or change the surface location for your northern and eastern side elevations. To again, you're designing to regulate the gains and losses in the building, and like I said, using multiple either different low E's or different surface locations. Again, that'll help to regulate some of those the gain or loss situations. Building placement. I know sometimes that can't be helped on which way the building faces, but orientation of the building itself can help with the different exposures the building sees. And again, going back to the window to wall ratio, you could design the building with potentially smaller or larger window sizing on one side or the other to again help regulate your heat gains and losses at those different exposures. Another thing, it's kind of off topic, but another thing is to design the interior spaces depending on usage. If they're not high use areas, like I said, you might want to you could potentially get away with a smaller fenestration product, more office type area or open space. Again, larger window to wall ratios might be more appealing. Fenestration, or excuse me, HVAC. A lot of the times HVAC is becoming increasingly efficient over the years, and it's obviously much more easily replaced than the fenestration. But there's a breaking point where changing out the HVAC is just not going to cut it. We're starting to see in a lot of the codes, especially some of the green codes, trade-off limitations. We're looking at envelope backstops so that it's forcing more of a look on the fenestration rather than allowing the trade-offs. Using that better fenestration, again, it'll help you to use smaller HVAC equipment to satisfy the building loads. And potential for upgrading that HVAC system could happen. If you add expansions onto the building, so there's still an option there, but you're using a smaller HVAC size, again, potentially, hopefully lowering that energy use using that smaller equipment. Commercial buildings are often around for many decades. And this becomes increasingly evident when reviewing some of the commercial data on the commercial building stock, with many of those buildings using clear glazing, non-thermal barrier framing systems. While again, many of the new buildings are using the latest technologies, we still need to address that total energy usage aggregated across all the buildings. Briefly, I wanted to go over just a quick example, just to kind of give you an idea of what does window replacement do for you. This was an actual project that I was involved with. So it was a high-rise condominium building in Philadelphia, PA. It was built in 1976. There was 10,000 square feet of window square footage. And the problem that started the whole thing for wanting the window replacement was occupants were complaining of frost and condensation on windows, cold drafts in the winter, and the windows were hot to the touch in the summer. So the existing windows that were installed in the building were aluminum frame, clear glazing unit. So again, not much for thermal performance. Just I pulled some information here. These are center of glass numbers for what a clear glass for this particular one using clear glass. Actually, I believe this is whole product. So it's 0.56, 64 solar regain 71 VT. Environmental conditions they decided upon. They used the 99% number from the ASHRAE handbook. So they used 19 degrees for winter design temperature, and they did a poll of the occupants where they maintained their set points between 70 and 72. So for conservatism, they went with the higher number of 72 and used that for the analysis. For the replacement windows, they decided they wanted aluminum thermally broken frame with low E argon fill. Again, U factor went down pretty substantial, 0.39. Solar gain 3.5, 6.3 for the VT. Same environmental conditions. Okay, now here's a comparison of the existing windows to the new replacement. I just used a recent national kilowatts of 12 cents. Like I said, that's going to vary per location. I just use that as a baseline, or just for this example purposes. So if you look at the data, comparing everything, figures looked initially, like I said, looked pretty awesome. $30,000 you're gonna save with the window replacement. But that value there actually needs corrected because that's assuming it's winter 365 days a year, which we know that's not the case. So if you do the recalculation based off of only heating, the heating days, it's still a pretty considerable savings, but it's about $14,300 annual savings for installing those windows. And then again, you have additional savings in the summer because they went with the solar heat gain that was lower. So you're going to reduce the cooling requirements in the summer. And the glazing that they selected was only an 8% reduction in visible transmittance. So again, with the window replacement, you're saving, I believe it was close to 133,000 kilowatt hours a year. So that's pretty good energy savings from the windows. And again, you're seeing annual cost savings as well from that installation. More importantly than the cost savings, the energy savings, there was other realized benefits from the window replacement. Tenant comfort was addressed. Drafts from infiltration were addressed with the new tighter seals from the new windows. Thermally broken frames had a higher resistance to condensation, resulted in warmer frames. The windows felt warmer to the occupants, gave them that additional comfort. Again, the new glazing had a lower solar heat gain. So again, to reduce the cooling costs during the for the air conditioning in the summertime. Again, the other benefits would be building is now, it was actually worth more and had a better resale value, because the new owner now would not have to do the retrofit or replacement on that building. And it turned out too that the building owner was offered a tax credit and a rebate from the utility company because of the replacement. And the last item here is the building now has that better chance for potentially meeting green building performance standards that may be applied in the future. Many cities now are implementing these standards and applying energy use intensity requirements for the buildings. And it's essentially how they're calculating that is it's the total energy consumption divided by the square footage of the building. Okay, let's move into some glazing technologies. So we talked about methods to help save energy. Let's talk about just briefly a couple physical products, such as glazing technologies aimed to reduce consumption, and it could increase occupant comfort. The use of applied films can help to improve the solar control into the building space. Again, provide some comfort, especially on southern and western exposure elevations. Some of these films additionally can be provided with U-factor benefits depending on the product type out there. There's also some on the market that provide UV control, which will help the negative effects to occupants with prolonged exposure. Exposures coming through the fenestration product, and also reduces fading on interior finishes. These films can either be factory applied or applied post installation. Some emerging technologies that I wanted to talk about: vacuum insulated glazing. They're gaining more widespread adoption, or more traction, I guess, in the industry. Basically, for those that don't know what these are, it's two pieces of glass separated by some type of pillar array, and the center gap is evacuated. They basically pump all the air out of it. These types of glazings, they have high resistance to heat loss. There's some claims out there. They're R10, R15, R30, and the R30 is a new proprietary. It's a triple pane VIG. Most of them recently are only dual pane, 2 panes of glass. I've seen one out there now that they have 3 panes of glass with 2 evacuated gas layers, or I guess not gas, but it's evacuated gap. So vacuum glazing is not a new technology. It's been around for many years now. It was back in the probably 50s, 60s. Again, it's the technology is advancing. The cost associated with them was a big barrier, but I think they're coming up with new methodologies now that are making these more mainstream. And one thing to note is VIG. It's widely used in other countries like China and Japan. We're just now, like I said, seeing more of those type products. Thin triple glazing. So triple glazing has been around the marketplace for years, with equal glazing thicknesses, or potentially 6 mil, 3 mil, 6 mil glazing. Like I said, that's been around for many years, but now there's an incorporation of a very thin center layer, and this application is helping with weight limitations, and also helping with the thickness of the unit. You can actually get these installed in normal dual pane assemblies. You don't have that additional width like you would with a true triple glazed assembly. One of the things I think is interesting is kind of reminiscent to me of heat mirror technology. That was back. I think it's still potentially used. It's a thin plastic layer that was used between 2 panes of glass, and essentially what the thin triple glazing helps out with is it allows for additional low E surfaces to be applied, allows for the additional gas chamber. You have two air gaps instead of the one, and all of these help with thermal performance. Last item here, I want to talk about glazing technologies or thermochromic, electrochromic, dynamic glazing. Essentially what these do is they help with solar control. Thermochromic changes tint states with temperature, kind of like transitions classes that you may have. Electrochromic are controlled by electric charge, and they can be automated depending on how they want to regulate the solar gain. Okay, conclusions here. Commercial buildings, again, are spotlighted as large energy consumers, and that's for a reason. Large buildings, everybody sees them out there. And these buildings are going to be tested with new green initiatives, with some regions preparing to issue fines for non-compliant buildings, all in efforts to reduce energy consumption, greenhouse gas emissions. In the future, older vintage buildings are going to need to undergo some type of replacement, and new construction are going to need to continue to use the higher performing products to satisfy code. Again, as codes become more stringent, this will be the main driver in adoption for energy efficient fenestration. The commercial marketplace, we all know, it's fast paced, but realizing the benefits of properly specified fenestration can be attained through proper planning early in the design phases. More communication should happen between architects, engineers, developers to integrate energy efficient fenestration as a default, rather than going with lower performing. As you know, there's other benefits from the energy savings. Like I said, there's the occupant comfort. There's other influences that some of these higher performer systems can offer. Additionally, this cost could be rolled up in the design to maximize savings. So that could allow for these newer technologies to be installed. Products that obtain the certification can help benchmark regional performance targets and assist in code requirements. Every building has the opportunity to obtain that certification for the installed products. And again, it's most of the time required by code unless the project doesn't get reviewed. Collecting building performance data can have a significant impact on informing and motivating the building industry to consider the importance of fenestration in the overall building performance and encourage implementation. And one final note here, I just wanted to briefly shout this out that NFRC 715, it's a new commercial program that's what I was talking about in the beginning for the commercial trendline approach. It's a trendline methodology to calculate thermal performance of products. That is going to be code compliant. Again, these are NFRC 100, 200 standards, and they'll comply with ASHRAE 90.1. Allows for custom products, custom facade products to be rated, those custom one-off products to be rated as well. So should all help designers, with getting those certified products that meet that code compliance. And with that, just want to thank you for your time. And here's my contact information. Should you have any questions we don't answer here, if you want to talk about anything.
Kevin, looks like we got a couple in the queue here. The first one, what are some of the differences between commissioning fenestration systems versus formal actual envelope commissioning?
Envelope commissioning is a little bit different. There's a lot involved within envelope commissioning. It's not just thermal. So I'm trying to see here the difference between commissioning fenestration systems and formal. I think I might need some more information on that, but essentially somebody's going to specify the product to be used. And then, like I said, the performance performance values and certificates got to be generated. I don't know, I may need some more information on clarify what they want there.
Okay. And we have another question. What is the life of the electrochromic glass? This person says heard it's 15 years, and at that point you are replacing all the glass as it fails or putting up window shades.
Yeah, I that's a good question as well. I don't work with the electrochromic glazing people, so I don't know what the experience is out there with the durability on them. I know that technologies are out there and can be used, but that would be a good question to specifically reach out to one of those electrochromic glazing manufacturers to see if they could give you some more information on that.
Okay, thanks, Kevin. I don't see any other questions in the queue, but we'll give it another minute or so. If anyone has any questions, please feel free to drop them in the Q&A chat. Kevin, I don't think we've got anything else that's going to come in at this point. So I guess with that, we will, we'll close things out. Again, we'd love to, we want to thank you, Kevin, and everyone who's joined us here, including our members across all 3 affiliated organizations. We are very glad to have this opportunity ongoing to connect. Everybody participating should keep an eye out for an email with information regarding your learning units from today's session. And a reminder that we have in-person energy management professional training May 2nd and 3rd at the CX Energy conference, which is being held in Fort Worth, Texas at the Omni. This is part of CX Energy 2023. And it is approved for 12 AIA LU continuing education credits. And we look forward to seeing you there. And we thank you all for joining us today.